So in this short video, we will go through the problem 2 in exam practice. So in this problem, it is saying that an approach has the saturation flow rate of 1800. So the saturation flow rate is 1800 vehicle per hour. And then it says during one 80-second cycle. So the cycle length is 80 seconds. And what's more, there are 4 vehicles queued at the beginning of the cycle. So 4 vehicles at the beginning of the cycle. And what's more, 2 vehicles queued at the end of the cycle. 2 vehicles at the end of the cycle. And at the beginning of the effective grain, there are 10 vehicles in the queue. So 10 vehicles at the beginning of effective grain. Moreover, the arrival rate is constant, so mu is constant, and the process is deterministic. And assume that effective rad is less than 40 seconds. So R is less than 40 seconds. And it's asking you to answer the following questions. So find what are the effective rad and grain times, as well as the total delay. So to solve this problem, we need to draw a queuing diagram first. So for a queuing diagram, this is our x-axis and this is our y-axis, the number of vehicles in the queue. And then if we assume these 4 vehicles to be quantitative 1, 2 vehicles to be quantitative 2, and 10 vehicles to be quantitative 3, so then we can draw those 3 quantities in this queuing diagram. So we know that in a cycle we have 2 parts. The first part is the red part and the other are the green. So the total cycle is given in the problem. It's 80 seconds. And then, so for this Q1, 4 vehicles at the beginning of the cycle. So here we know that from the beginning of the cycle, it is 4 vehicles. And 2 vehicles at the end of cycle. So this is what we also call residual queue. And then 10 vehicles at the beginning of effective grain. So we will firstly draw the arrival curve. So here we'll have 10 vehicles at the beginning of effective grain, which is this time point. So if we draw the arrival curve as this, so the slope here is lambda to be constant. And then for the departure curve, we know that the saturation flow rate is 1800 vehicle per hour. And we know that for an intersection, the departure rate is equal to the saturation rate. But here, we need to convert it into vehicle per second because in the queuing diagram, the horizontal axis is in the unit of second. So there are 30,600 seconds for 1 hour, so that gives us 0.5 vehicle per second. And then we know that for the departure curve, we will start from 0, and then for the end of this cycle, let's draw here, we will have 2 vehicles as the residual. So to solve this problem, we don't know the R, G, or lambda, but we do know the departure rate to be 0.5, and we know 3 different quantities. We will use those quantities to establish equations. So first of all, in this part, we know that here the slope is lambda, and here is 10 and here is 4. So if we use this 10 minus 4 divided by this r, so it should equals to lambda, which gives us lambda equals to 6 over effective rest time. And what's more, here we also have a 2, so that's the differences between this arrival curve and departure curve. So we will start from this time point. That's the beginning of the effective green time. Here we can know that for this arrival curve, we start from this point, so we will have an initial of 10, and then the time here is g, it's lambda times g. And then for this curve, we know that it starts from here, and the time is also g. The slope is 0.5, so 0.5 g equals to the differences between those two curves, which are 2. And then we have two equations. And we also know that the effective green time equals to cycle minus the effective rest time, which are 80 minus r. So here we have lambda in terms of r, we have g in terms of r, and then we plug in equation 1 and 3 into equation 2, and then we can solve for quadratic equation. So this is 6 divided by r times 80 minus r minus 0.5, 80 minus r equals to 2. And if you solve for this equation, we can get that we have two solutions. So the first one is 16 and the next one is 60. And we know that r is smaller than 40, so we will choose r as 16 seconds. So that's our effective rest time. And for effective green time, it equals to 80 minus 60. That's 64 seconds. So that's for the first part. And for part B, we would like to calculate the total delay. And as we know, the total delay equals to the area, the differences between those two curves. So to calculate that, we need also calculate the departure rate, the arrival rate. So lambda, we know that equals to 6 divided by r, which is 6 divided by 16 to be 0.375 vehicle per second. And for the total delay here, we have two parts, two trapezoids. So first one is this, and the second one is like this. So it equals to, here is 4 plus this 10 times the height here, which is 16, and then the other one here is 10, and here is 2, and the height here is 64, and this gives us the total delay of 496 seconds, and that's for the problem 2.